We are now starting with lotic systems. Just to remind you, lotic systems are flowing freshwater systems. And the ones we are going to look at are streams and rivers. Some basic terms that I need you to understand before we actually continue with more detail. Firstly, the word catchment. Now, you can interchange that word with the American word watershed, which you will find in most textbooks and on the internet, or the word river basin, which a lot of you possibly learnt about in geography. We prefer in ecology to use the word catchment area, and that is what is most used in South Africa, especially in the conservation sector. And it refers to an entire area that is drained by a river system. You may have learned the definition slightly differently at school, but it doesn't matter. What it comes down to is that a river drains an area. Now, in class, I would have probably asked you firstly, what do you think is the main or original function of a river? And if you think about it, how do rivers form? Well, rivers form because water falls on a mountainous area or a high-lying area, and that water must go somewhere. So it will flow downhill. And if this happens over and over and over again, that water will scour out a channel for itself, and that channel will eventually become a river. That's how rivers form. And the rivers, as I hope most of you know, flow from a high-lying area to the ocean. Well, we'll get to that on the next slide as well. So, to come back to what is the original function of a river, well, it is to drain an area. That's how it actually forms, is by drainage. So we look at the catchment as that entire area that's drained by a river, and it's not just a mountain, it's all the areas from where streams come, and you'll see that also on the next slide. So it's quite a large area. So a catchment area is much larger than just the river itself, as you'll see just now. The next thing we're going to be looking at is streams. Now, streams make up rivers, and streams are classified according to specific orders. They are given numbers, as you'll see in the next slide. Number 1, 2, 3, 4, 5, etc. And these numbers are called orders. First order, second order, etc. And that number depends on how small they are and where they are positioned in the entire river system. Then we have the river itself. Now, we usually talk about, in ecological terms, about a river as being a mature and proper river if it's large enough that you actually start getting to seventh order streams. Again, you'll see on the next slide what I mean. You've also heard the term tributaries. A lot of people talk about tributaries. Now, tributaries are branches or streams that enter a river system, but it's a lot more than just that. It has to do with their specific order, the number that have been given to them, and you'll see that also. I'm just going to read through this with you, but I'm going to explain it on the next slide. So it's a branch or stream of a lower order, let's say maybe a second order stream, that enters a stream of a higher order, let's say a third or fourth order stream, and it doesn't change the order of those receiving streams. It doesn't physically change the stream either. So you've got a small stream, smaller one, flowing into a larger stream, and it doesn't really change anything, just adding a little bit of volume. Then we have something called a confluence. The word confluence is is used for any situation where two streams or two rivers meet each other. So we talk about the confluence of the two streams, that place where they actually come together. Let's go to the next slide. Now, don't get a huge fright when you see this slide. I'm not going to ask you to draw this entire thing, but I could ask you to maybe draw a small section of it. So it is important that you understand it. Now, the first thing you see here, you see mountains. And you see an ocean. Now, of course, I couldn't draw this in 3D, so you've got to think 3D here. And so, obviously, mountains are high-lying areas, so you've got to think that all of these streams run along a gradient all the way to the ocean, down towards the ocean. So that's the direction in which the water flows. Right. Now, if we talk about the catchment, what would the catchment be? Well, it would be this entire area that is drained by all of these streams. Right. Now, you'll see that the streams are given numbers. So you'll see the ones in the mountain have got a number 1. They are these smaller streams. You're going to see that also later on. They are these much smaller, the tiniest streams, first ones. So if the rain falls on the mountain, those very first tiny streams are number 1, order 1 streams, first order streams. They run together. You can see here, there's a confluence of each of a 1 and a 1 to form a second order stream. You always have to have 2 first order streams to form a second order stream. What does that mean in reality? You're going to see later on, it means that second order streams are going to be bigger. And in reality, also, they actually already still found on the mountain. I just couldn't fit them in there. But they are still on the mountain. So you have to imagine that this is still mountain slopes here. They will be bigger because it's the water from both those first order streams running together. They will be slightly bigger. Then you have 2 second order streams running together. There's the confluence, and it forms a third order stream. In reality, what does that mean? The third order streams are slightly bigger because they now accommodate the water of that whole all of those streams together. Then you have to have 2 third order streams to form a fourth order stream, 2 fourth order streams to form a fifth order stream, etc. And it's only when you get to the 7th order stream, and you can have in reality with our the biggest rivers in the world, when you get to rivers like the Nile and the Amazon, where you can go higher than 7th order. You can have 8th and 9th order streams even. And that then eventually flows into the ocean. What you also can just imagine for yourself is that somewhere along here, probably from around 4th order streams, the gradient starts getting a little less because it's now a bit further from the mountains. And then especially when it gets to this area here, the gradient is a lot less when it gets closer to sea level. Okay, just in case you wondered what did I do here with the dotted lines, I just made it easier for myself because I couldn't fit everything in here, because that 1 to 5 would have meant I would have had to draw a whole thing like that again, just in here and here. But you can really imagine for yourself how big this river system must actually be, because this is what we call a mature river. Now, there are exceptions in nature when it comes to river systems. Most of them start in mountainous areas and then go through all of these little streams to eventually get to this much larger part of a mature river. But we have local exceptions in our on the southwestern and southern Cape Coast, where we have rivers that start in on coastal hills, and because the distance is so short between the coastal hills and the estuary or the river mouth, um, by the ocean, that little river is very, very short, and it doesn't go through all of these stages. So there are exceptions like that. And there are even rivers that start in more low-lying areas. But this is the more traditional type of river that you're going to find most often in the world, and especially in larger river systems. And so let us just have a look now at some of the terms that I talked about on the previous slide. So the catchment, I said, would be this entire area, which is drained by this entire river system. The streams are all of these things with numbers, up to and including streams number 6. And when you get to 7 now, you can start talking about it as a mature river. What is interesting is in our country you'll see that even a stream close to the mountain will have a name with the word river behind it. And it's quite confusing. It's just the way that we talk about our water bodies, our flowing water systems, but it isn't really a true river. So something like, for example, the Liesbeek River. If you go and look on a map, the Liesbeek River and the Black River, they come together and form the Salt River. So they are actually streams of the Salt River. So they themselves don't really have their own upper, middle, and lower reaches, which is what we're going to be looking at later on. They don't have their own, or all these specific numbers of streams. I've just mentioned a few words now, upper, middle, and lower reaches. We're going to be talking about that just now. But the upper reaches, or the headwaters of a river, would be these small order streams. So orders number 1, 2, and 3. These are still very small streams. And then everything 4, 5, and 6. These are bigger streams. They are called the middle reaches of the river. And then everything from 7 and further, as I said, there could be bigger rivers that even have 8 or 9. That would be the lower reaches of a river, and then considered, the whole system then considered a true mature river in ecological terms. Now, another term that we saw on the previous page was tributary. And I said to you that a tributary is a stream of a lower order that enters a stream of a higher order. I'm going to show you an example here. There we go. So this is an example. Here's a stream with a number 4. And you can see it runs into a stream with the number 6. So the number 6, the 6th order stream is obviously much bigger than the number 4, 4th order stream. And can you see that if you look at the numbering, it remains a 6th order stream. It doesn't go bigger. It doesn't now suddenly become a 10th order stream or a 7th order or whatever. It remains a 6th order stream, and that is because this 4th order tributary is smaller, so all it adds is some volume, but it doesn't really physically change the environment of this particular stream. So when you have to define tributary, remember that part as well. So it's got two parts. It's got the part of it being of a lower order entering a higher order stream, but it's also got the second order part of the stream order remaining the same, the receiving stream, the one that it flows into, that one will remain the same. Okay, I think I've covered all of those points. Now what you will see is, and this is what we're going to be talking about now, is that stream conditions change from the mountains down towards the ocean as the streams become larger and wider. Here you've got a photo, I put it on the front slide, first slide as well, where you go from a mountain stream to the foothills, upper and lower foothills, and lowland river. So in other words, when you're not on the slopes of the mountain anymore, but you can see that the structure changes. Here you can see a lot more rocky, and it doesn't run as fast here anymore as it does there, and then it doesn't look like it's running at all. So we're going to be looking at that change, because that change is very, very important. Here you can also see just this drawing. You'll see this part represents the upper reaches, this part the middle, and this part the lower reaches near the coast. You could see how the river becomes wider, and also organisms change, and we'll look at that later on. So the river is divided into upper reaches or headwaters, which is first, second, and third order streams. I'm just going to run through these next few slides. Then we have the middle reaches, fourth, fifth, and sixth order streams. And then we have the lower reaches, seventh, eighth, ninth order streams, where you then talk about a mature river. And so we are now going to look at the characteristics of each part of the river and how it gradually changes, and what is important about these changes. So in our next video, this is what we're going to be talking about.